Yeni bir helikopter tasarlamak kolay değil. Özellikle de bu helikopter bir roketle hayatta kalması, Perseverance aracına konuşlanması ve 200 milyon mil uzaktaki adamlar tarafından kontrol edilmesi gerekiyorsa. NASA'nın Ingenuity'si, Dünya dışındaki bir gezegende uçan ilk makineli hava aracıdır. 500'den fazla parçanın tümü, Mars'ta yani Dünya dışındaki bir gezegende uçmanın zorluklarını karşılamak için tasarlanmıştır. Ingenuity geçen ay başarılı oldu. Bu sebeple daha fazla uçuşa hazırlanıyor. Peki NASA neden Mars için bir helikopter tasarlamaya karar verdi?
To prove that we can. It's a simple answer.
Mars için bir helikopter tasarlamanın zorluklarını öğrenmek için JPL mühendisi Ted Ignatius'un röportajını aktaralım.
There is no manual, there's no instruction sheet, NASA hasn't done this before. It's an evolution of baby stepping and tackling the next biggest technical challenge each step along the way. In the month of Ingenuity and getting our flights has been, on one side of the screen, putting up our models and saying, this is what we think a helicopter should do based off of everything we've done here on Earth. And then on the right side of the screen, we put up the actual results and we say, okay, this is what Ingenuity actually did. And you line them on top of each other and it's an almost perfect match.
Mühendislerin karşılaştığı en büyük uçuş zorluklarından biri Mars'ın aerodinamiğiydi. Çünkü Mars atmosferi, Dünya atmosferinin yoğunluğunun %1'i kadar.
You move your hands around here on Earth, you can kind of feel the hair on your hands moving around as a result of every action has an equal and opposite reaction, right? You feel you're actually pushing the wind. Imagine now 1% of that sensation on your hand. That's how little air we're talking about.
Mars'ta uçmak, Dünya'da 100.000 fit yükseklikte bir helikopter uçurmak gibidir.
So there's not a lot of air to produce thrust to move up. So to give yourself the easiest job possible, you want to keep your vehicle light. And that kind of means around the area of 2 kilograms.
Ingenuity normal bir kediden daha hafiftir. Pervaneler rover'a sığacak kadar kompakt, aynı zamanda kaldırma için de yeterince hızlı olmalıdır.
That means that your blades need to spin around, we're talking about 1900, 2800 RPM. That's super fast.
Bunu daha iyi anlamak için dünyada 400 ila 500 RPM arasında dönen helikopter kanatlarının dönüşüyle karşılaştıralım.
Most people are familiar with a single rotor spinning and then a tail rotor that counteracts your yaw torque. Those two rotor systems, if they counter-rotate, they can cancel out that yaw instead. And then can also produce thrust on top of each other and still give you positional control.
Ve ilk 5 uçuş. Ingenuity toplamda 8 katlı bir binanın yüksekliğiyle yaklaşık olarak eşit olan neredeyse toplamda 91 fit uçtu. Bir başka şaşırtıcı aerodinamik zorluk ise düşük yerçekimiydi.
It's actually nice that the gravity is less on the surface of Mars. It's about 1/3 what we have here on Earth, and that makes it easier for the vehicle to actually get up off the surface. That makes it difficult for here on Earth, though, because how do we test that? We don't have anti-gravity technology. There's no way to cancel out the gravitational field.
Bu sebeple mühendisler düşük yerçekimini taklit etmek için bir yerçekimi boşaltma sistemi kurdular test aşamasında.
You can think of it like a high-tech fishing reel. We attach that several stories above the helicopter in our vacuum chamber, and there's a control loop that many times a second, it just senses how much torque it feels. That torque over a fixed radius pulley gives you the tension on the line, and we just have a controller that's dialing in that torque to give you a fixed tension, and that fixed tension cancels out the difference in gravity between Earth and Mars.
Mühendisler ayrıca Ingenuity'nin düşmeden kalkış ve iniş için yeterince kararlı olduğundan emin olmak zorundaydı.
After we first landed on the surface was for the Ingenuity team was to do our kind of flight zone selection. That whole site selection process was very particular about the number of rocks at certain distances apart as different sizes of rocks to give us the best location to fly on.
Peki ya o meşhur Marslı toz fırtınaları?
You ready?
Ready! Hollywood tends to exaggerate a little bit the capabilities of Mars windstorm. Because of that 1% density, there's not a lot of matter hitting you, right? And there's not a lot of momentum being imparted upon you because of that. So we're not too concerned about a dust storm coming and knocking us over.
Sadece mühendislerin Ingenuity'yi uçurması gerekmiyordu. Helikopterin her gece donmasını önlemek için bir çözüm bulmaları gerekiyordu.
A lot of no pun intended, energy, but a lot of time was put into designing the thermal management system for Ingenuity.
Mars eksi 90 santigrat dereceye ulaşabilir ve mühendisler Ingenuity'nin beynini korumak amacıyla kamerasını, bilgisayar kartlarını ve pillerini tutan Ingenuity'nin beynini saran kutuyu parlak altın malzemenin 2 katmanıyla sarmak zorundalar.
We have our metallized polyamide film. That's our inner insulation layer, and then we have an outer insulation layer. By preventing those circulation currents from flowing, you minimize how much heat winds up leaking out to the outside surface, and you keep your precious components warm throughout the very, very cold nights.
Sadece pili sıcak tutmanın ötesinde mühendislerin pili şarjlı tutmaları da gerekiyordu. Çözüm güneş paneliydi.
That's our font of energy. That's where Ingenuity recharges. It's a rectangular panel, and it's about a foot long, I would say a little less than a half a foot wide. Whenever photons are hitting the surface of the solar panel, we're taking those in and we're shoving them into the battery. You'll see 3 rows of solar cells on top, and those 3 rows all combine to give us all the energy that we need to charge soul after soul.
Bir pilin bir tek hücresi, bir cep telefonu pilinin ömrünün yaklaşık yarısıdır.
And that's what we use every single flight, every single day, every single moment to keep ourselves warm, to run telecom, to speak back with, mission control here on the ground.
Ve nihayet mühendisler helikopteri yaklaşık 200 milyon mil öteden nasıl kontrol edeceklerini buldular.
So we have our solar panel with our little telecom antenna on top, and that is our link back to mission control here at NASA JPL. All of the data and commands sent here from the ground, we uplink that to the orbiters. Orbiters then relay that to the rover, and then the rover sends that to our base station, which then sends it back over to the helicopter.
Ingenuity'nin Mars'ta yaptığı her şey kod ve algoritmalar tarafından otonom olarak yapılır ve JPL'deki mühendisler hesaplamaların doğru olup olmadığını görmek için iletilen verilere bakar. Burada yaptıkları bu.
This is downlink. We've pulled in data products from Mars 2020.
Little insider baseball here is, depending on the size of the data, we sometimes know how things went. We're sitting there at our stations waiting for the first bits and then the last bits to hit the deep space network, to hit the receiving stations here on Earth, to then get forwarded over to JPL. Once we verify data's down and our pilot has confirmed that we've flown, then we can celebrate and say, yes, now we know for sure.
Ancak hazırlanılamayacak bazı zorluklar olabiliyor.
After we were dropped, the rover took some very nice images of Ingenuity and specifically of the solar panel. And we noticed that, there was definitely some dust there that we think may have accumulated either after we were deployed. And we're looking right now, we're doing the data mining and analysis. One of the cool aspects of having all this data is you can go back looking at how did the solar panel do before Flight 1, before we really started shaking the system, and then after Flight 1, how does that change? That is definitely one of the interesting aspects of having an aircraft, is that you're not physically static. You maybe can use your propulsion system to try and clean off your solar panel, but we'll see. Work to go.
Ingenuity tekrar uçtuğunda aracın görüntü yakalayıp bataklık ve arazi üzerinde keşif yapacağı operasyonel gösteriler aşamasını başlatacak.
We've proven that humanity can fly on Mars. We're trying to push that envelope even further and learn as many lessons as we can. Eventually, parts will fail. It's going to happen, right? We are using COTS parts. We are not as reliable as the rover. We are not as reliable as a Class A mission that's designed to survive months and months and months, right? So it's going to happen. We're ready for it. We'll look back to these 3 points that, we've flown, we got the data down, and it's not a fluke. We did it 5 plus however many we're lucky enough to do in the operational demo. So, as happy as can be. It's been a dream come true, and we're just trying to continue that as long as we can. When the operational demonstration's over, wherever she touches down for the last time, that'll be where she stays. In terms of the long-term future, she's already home. So that's where Ingenuity is meant to be. I can't wait to see what comes of this and what humanity can do as a result of this. The idea of being able to carry meaningful science payloads in the future, maybe one day helping the first astronauts that land on the red planet. And we're excited that Ingenuity has now enabled that.
Bring me back to where we started.